3D printing and design, where imagination takes shape and innovation knows no bounds. Hello everyone, I'm your host Dalvinder Kaur from Lovely Professional University. Get ready to dive into today's topic, that is 3D printing and design. Before we proceed further, allow me to introduce the experts of the day. Dr. Vishal Francis, Assistant Professor, School of Mechanical Engineering, Lovely Professional University. An esteemed expert in the field of 3D printing with a PhD specializing in 3D printing of nanocomposites. With over a decade of experience in academia and industry, his insights into high performance material development, 3D printed electronics, and the application of AI, ML in 3D printing promise to be invaluable. And now I would like to introduce admission nominee also in this webinar, Dr. Mahendra Singh Kaswan, an associate professor at Lovely Professional University, earned his PhD from the same institution in 2021 and his MTech from NIT Kurukshetra. His research spans industry 4.0, 5.0, net zero, lean six sigma, and more. He's also a member of distinguished organizations like the Indian Science Congress and has excelled in the graduate aptitude test in engineering, that is GATE, multiple times. Before we proceed further in today's session, I would like to request everyone, for any question you can write in the chat box or in the Q&A box, and same will be addressed from my side in the end of this webinar. And now I hand over the thanks to Dr. Vishal Francis, and it would be an absolute delight to listen from him. Over to you, sir.
Thank you, ma'am, so much for giving me this opportunity. So without any further ado, we'll start. Let me just share my screen with all of you. And I will be needing a confirmation that my screen is visible. Yes, and voice is clear.
Screen is visible, everything is okay, you can continue. You can continue, Dr. Vishal. There's some network issue. So we'll join in 2 minutes. Dr. Vishal.
Yes, ma'am.
Yeah.
Some connectivity issue.
There's some network issue.
Yeah.
Kindly share your screen and continue.
So is my screen visible?
Screen is visible, sir.
Screen is visible?
Screen is visible. Yes, sir. You can continue. Screen is visible.
Okay.
Sorry for the delay.
So today we'll discuss about one of the very important topic, which we call it as 3D printing and design. And this is one of key area, or you can say the thrust area, announced as one of the promising area where students, especially engineering students, should study it, understand it, and use it to solve the real life problems that we are facing today, our society is facing today. So let's move into the presentation outline. Today I will be discussing about the technology, what basically is a 3D printing technology, and I'll try to give you an overview of it. We'll talk about some of the very important aspects in terms of applications of 3D printing, whether it's an industrial application or a biomedical application. And then I'll try to classify this thing because it's kind of a family of technologies which I call it as additive manufacturing or 3D printing. And then I'll talk about a bit about the uh, materials, which are the building block for the 3D printing. So let's start. So before I get into what is 3D printing and what is design and how important it is, I'll give you a small case. So we are, and we heard about these companies, the companies, Honda, Nissan, and Suzuki, and so forth companies. Now, during the time around in 1987, the case of issue that started coming up for the press release button that we have in our automobiles, and this particular button was uh, uh, and it was in the see this 52 series buckle assembly, and this is a figure I've taken it from 1987 Honda Accord. And now, gradually, people started getting issues related to the functionality of this particular thing. And the issue was that the upper one is something which is intact, that it should be like this, something like this, it should be. But after the usage of this press release button, there was a malfunction, and this part, this small portion was breaking. This was after the usage, it was started breaking. So people started investigating why this is happening, and it's happening in all these companies which were using this particular 52 series buckle assembly. And then investigation was that the reason why this is happening is because the material that was used was an ABS polymer, and the issue with the material was that it started degrading on the exposure of UV rays, and this is what was happening. And another issue was that people suggested that why not we provide the reinforcement into it. So this, if you can see in the below figure, this reinforcement. So if we do this, we can actually change the design, and hence we can actually protect the design and the functionality. We can preserve the functionality, and this malfunctioning can be avoided. So these are the two things. Now, why I just wanted to share this is because I wanted to highlight the importance of designing, which happens much before we start to manufacture something, much before we start to make important thing. And when the designers, when they start designing, the issue that they face is that if they come up with a very complex design, and with it may be a very creative design, but the constraint that they have in their mind is the manufacturing part, that if they come up with a complex design, then they have to look for the ways through which they can actually manufacture it. And if the company doesn't have those manufacturing facilities, then these designers have to come again in the design phase, they have to change the design. So they were not getting the freedom that they want, the design freedom that they want. Because if they have free mind, they can use their creativity and they can come up with very good solution to solve the problems. But here, because of the restrictions imposed by the manufacturing facilities that they were not getting that much of freedom. But by the introduction of this technology that today that we will be discussing about, that we call it as 3D printing or additive manufacturing, it is So let's get into this technology. Let's have a look. So this is what I was trying to tell you, that how it is giving us a lot of design freedom. Now the designer have a lot of freedom. They can design any complex part. Now they don't have to much think about the manufacturing facilities, because this technology, 3D printing, it's going to give us the facility, the capability. It has the potential to fabricate any complex design. So if you can see these two design, I've just given it for a reference. These are very complex designs, very free form shapes, very intricate shapes, and this can be easily manufactured by 3D printing technology. Another very important thing about this particular technology is the innovations in the healthcare industry. Now, healthcare industry is one of the industries where we people from different backgrounds, they work together. People from material science, from biomedical, from computer science, electronics, mechanical, everyone contribute this to this particular field. And when we want to make products, we want to make devices for surgeries, we want to make devices for some kind of to do some kind of diagnosis, we have to fabricate. And many times, even if you want to make an implant, implant something which is totally patient specific, right? It's totally patient specific. So now if I have some kind of manufacturing technology which can make any kind of complex shape, then that particular technology helps a lot in that particular technology that can give us a freedom to fabricate we want in our medical device, that we want in our that this particular technologies has. Some of the examples, so you aerospace industry, the automobile industry, how they have embraced this particular technology, right? Now this example, if you see, we have what we call it as mass customization. Now these two terms are totally different. Now when we talk about customization, it's something we are making something for a specific person. We let's suppose we take a case of this shoe. So if I want to make a shoe specifically for a sports person, I need to get the details of their feet, right? And then I can use that data, and then I can fabricate, I can make the part, and then I can give them. Similarly for implant or any other thing that we want, customization is specific. And the mass, when we talk about mass production, that's a completely different field, where what we do is we do not customize, but we take the standard size, right? We try to standardize things, and then we produce them in mass, that is in bulk, thousands and thousands of pieces, because we have a standardized size, and then we can produce it, then these products can be sold. But 3D printing is something that is giving us the combination of mass as well as the customization. Therefore, we call it as a mass customization feature that we can get it from the 3D printing. So let's move forward. Now, this particular technology, actually, it has evolved over the period of time, let's say around 30 years or so. So when it started, people said, I am in the design phase, and now I want to see how my manufacturing or the production, we want to make up. People started using this particular technology, 3D printing technology, and they called it as rapid prototyping, because it was useful for prototyping something, right? And since the technology was so rapid, so we started calling it as rapid prototyping, and people started using it. Over the period of time, it evolved, the technology evolved, and then people started using it for tooling purposes. Tooling means like we are preparing some tools which will be used for the manufacturing. Let's suppose a die or a mold or a pattern, something like that. And then people, when they saw the capability of this particular technology, they started using it for making tools, because here we have a feature of making any complex part. any complex, intricate part, we can make it. So they started using it for tooling. Over the period of time, then people, when they saw the potential, they started investigating more. They come up with new ideas. The technology developed, materials were developed which can be used for this particular technology. And now what we have is, now we have this technology which is not only used for prototyping, which is not only used for rapid tooling, but now it is used for manufacturing end use products. So now we have automobile players, we have aerospace industry, electronics, biomedical, all these sectors, they are now using 3D printing or additive manufacturing for making end use products. Now moving ahead, now as I said, materials are one of the blocks, and we have a application as I just shared with you. If you can see that we have this for prototyping, this for the rapid tooling. It has applications in medical, for surgical planning, anatomical models. For in electronic industry, we have all these printed electronics, where we can use this technology and harvest the capability of making complex integrate features, and so that we can get a product which is actually solving the problem of the society in some of that. Okay. Now let's move and talk about the technology of 3D printing. Okay. Now before that, let me just give you a brief overview of how these particular things. So start with the aerospace industry. So NASA, Boeing, Airbus, GE, these are the big players, well-known companies into this aerospace sector. So now if you see this, what we have is, this is the picture we have taken it, and it is Airbus A350 XWB aircraft, and it contains over 1000 3D printed parts. And they have used a material which is Ultem 9085 resin. So it's a specific aerospace grade material. So now this particular airplane has around 1000 3D printed parts which are assembled. And why? Because now the designer have the design freedom. As I said, they can improvise their design. They can come up with a design which might be complex, but still they can reduce the weight without compromising the performance of the part. And if we can do this, then aerospace industry will definitely going to harvest it, right? So this is one of the things that we can, if you see this, that is one of the back, which is a very simple geometrical prismatic shape bracket, and very easy to manufacture. But when we apply design, and when we 3D print that design by a 3D printing technology, we can see that by optimizing the topology, providing the cellular structure, and then working on it, we can actually reduce the volume. You can see that the volume has been reduced 37% only, and they have used a titanium alloy grade. So drastically, significantly, we can reduce the weight without compromising the performance of the part. And this is one of the, you can say, something which can affect the aerospace industry. This is why aerospace industry is into this thing. If you see this figure, this is a 3D LEAP engine fabricated by GE Aviation, and they have already manufactured 30,000 pieces such. So why they use 3D printing? Because it has ability, and then what they have done is, they have, from 20 pieces, they have changed the design to into one piece, and this piece can be fabricated in one go. Earlier they were making 20 different pieces, only one piece, and we will get out this 3D printed fuel nozzle tip, right? So we can save a lot of time, which is complex. This design is difficult to manufacture, but with 3D printing we can do this. So that is why I'm emphasizing that this is something which gives a lot of design freedom to the designer. So the 3D printing is not only the manufacturing tool, it's a design come manufacturing tool. Let's move forward and see some other application. So now if you can see this, this is NASA refabricator, which is on the space station trash into the 3D printing stock, and then they have manufactured, they have designed a 3D printer which can work in zero gravity. It can work in zero gravity. It has been installed in International Space Station, and they have used it. They have fabricated the part in the space station. So if I say that the first this Earth, if somebody has manufactured something, it's due to the 3D printing technology which is there. Let me move forward. Coming to the automobile is another sector which is using 3D printing a lot. They are using 3D printing for different purposes. For example, functional prototyping, for making tools, as we discussed, for jigs and fixtures, for other automobile components. So you can see that I've taken few of these case studies just to highlight that all these companies, whether it is Audi, it is Ford, or whatever companies, it is Mercedes-Benz, they are using this for various purposes. They might be using it for prototyping, they might be using it for making tooling like mold, or maybe jigs and fixtures or component. So why? Because the technology has the capability, right? So here what we are trying to do is, from the initial years in engineering, we try to educate, inform the student about this technology, because in future we are going to see a lot of applications where additive manufacturing or 3D printing will be used. Moving ahead, we talk about the medical sector. 3D printing is one thing which they have actually they embraced 3D printing way back when they we can make parts which are complex very easily. The medical sector actually embraced this particular technology, because now what we can do is we can take a CT scan, right? We can take CT scan, we'll get the DICOM files, and from those CT scan, what we can do is we can segregate the region or segment the region of interest. Let's suppose surgery has to be performed. The doctors or the surgeon have to remove the scan. They will segment that part, the region of it. They will be using 3D printing to fabricate that part, okay, which is going to resemble the real tumor and the other organs which it is having. And then they can do the surgical planning before doing the surgery. Once they have it, they can plan the surgery, and then they can, as per the planning, they can execute the surgery. Now this can help in the blood loss, saving the blood loss, speedy recovery. So this is one thing medical industry has is using. So they have various application where this medical industry is using, for example, for making medical devices. You can see this is a 3D printed device for removal of cancerous tissues. And you can see that for the mapping, you can see we have this image has a matchstick. You can see the size of the matchstick, and you can see the size of these jaws which are there, and it has fine engraving over it, this thing, so that for the so minute features can be fabricated by this particular technology. And if you see for prosthesis, this is one of the example I have kept to show you that this is something which has been developed by some of the professors in USA, and they called it as cyber bees. And this is what they have is they have printed and for prosthetic hands, especially for kids who are not having the this functionality in their arms, hands. So they wanted to make something low cost. So places where people cannot afford prosthesis, they can actually use these devices. It's freely available in the internet, and they use 3D printing to fabricate it. And the cost was around, as they declared, it was around $50 or so. So cheap, and we can make this part, and it has certain functionality of gripping and ungripping. Because one of the issues with kids which require prosthetic hands is that as they grow, they actually outgrow the prosthesis, and if the prosthesis is very costly, then in many cases, in many areas, it's very difficult for them. So generally, what they do is they don't use it. But here now we have a technology through which something which is helping a society a lot, right? If you see this thing, these are the 3D printed transparent aligners. Generally, what we have material which are transparent, which we can 3D print, and we can print the aligners, right, which are transparent. So the patient can wear these things. They are transparent in nature. Not they will be not be change the aesthetics and other things, right? So in dentistry we have 3D printing. For surgical planning, as I discussed, for medical training, people are using 3D printing. So it has a lot of application in medical sector. Let's move forward. These are some other uh, applications of 3D printing in medical sector, like tissue, scaffolding, dental implants, safety equipments. People started using during the COVID period. People started using, they use 3D printing. Like one of the case of Italy where there was an issue with the nozzle, so they use the 3D printing, right? Let me move forward. This is one of the case study that I have heard, that one of the um, hospitals where what we have was a patient which had a very complex um, accident and fracture in this tibia bone. So the doctors approached us, we worked with them, and we took the CT scan data, we made a virtual model, CAD model, then we 3D printed that part. This is a scale down, and it took around 7 hours to print this part. And you can see all these are the fractured part. It was a very complex fracture, right? All these are the fractured part. And then they use it to plan the surgery. They did the surgery, and the surgery was successful. As reported by the doctors, a lot of blood loss was saved, speedy recovery. So how this 3D printing is actually contributing to the society. Moving ahead, I'll just give you a generic process flow of the 3D printing. A generic process flow of the 3D printing. Now, the first thing that we need to do is we need to prepare something what we call it as a CAD model, solid model, the solid model or the CAD model, right? And then we need to convert it into something what we call it as an STL file. And then once we have this STL file, we have to process this STL file, and then we have to prepare the data. And once we have this data, we go for the 3D printing process, and we get a part ready. And if required, we will go for the post processing operations. And if you see this, before 3D printing, what we have to do is, before I convert it into an STL file, and then I have to select the orientation. For example, if we consider this as a part, right, something that you want to print. Now you have to decide, like, in which way you want to make the part, in this case, like you want to make the part like this, or you want to make the part like this, or maybe in some other orientation. So that is something that a designer or the person who's using 3D printing has to decide. And then we'll prepare the data. We get the data which are the instructions for the 3D printer. We provide these instructions, set of instructions to the 3D printer, and the nozzle head or the laser, it will move, it will print the part, and we'll get a part ready. Once we have printed the part, if required, once we have printed the part, if required, we'll do the post processing. For example, if there are some support structure, right, you can see this red part is something which is a support structure that we create. So if required, we have to remove this, and once removed, we'll get the final part ready. So now, by doing like this, whatever I want to make, I'll just make a CAD model, that is computer aided design model, a solid model. And once I have this solid model with me, I can convert it into an STL file, and then I can make the physical model, which will exactly look same like what I have made in my computer, in my software, that is the solid model, right? So this is how we can make any complex part, because when I do this slicing operation, when I do this data preparation operation, what we are generally doing is we are breaking the complexity of the part. We break the complexity of the part, and once, and then we start making the part one layer at a time, one layer, then the second layer, then the third layer, and the fourth layer, and so forth. Will go and we'll deposit these layers, and we'll get a part ready. which will look exactly the same as we have created in our software, the solid model or the CAD model, right? So this feature of slicing it, it's something through which we are achieving any complexity. So what we are doing is we are breaking down the complexity of the part when we do this slicing operation. Okay, so let's move forward. Now, these are the few technologies. As I said, it's a group of technologies, or if you can imagine it as an umbrella. So additive manufacturing is a kind of an umbrella under which we have a lot of spokes coming together. All these are the different technologies. All come under the category of additive manufacturing, but the way they work might be different. In some technology, we use material in the form of liquid. In some technology, we use material in the form of uh, powder. In some technology, we use material in the form of sheets, or maybe in the form of a filament, that is something like a wire of polymers, right? So in, for example, in material extrusion technology, we take a filament of wire and then we heat it up and then we extrude it, as you can see over here, this thing. And the nozzle will move and it is going to deposit the material. So this green thing that you're seeing is something which has been deposited. And this is the part that we want to make. It will make the first layer, it will make the second layer, and from the bottom, it will start making the part in this upward direction. If you see this one here, what we have is we have a technology which is under the category of what we call it as VAT polymerization. For example, stereolithography apparatus or DLP. So here what we have is we have material in the form of liquid. Okay, so in a tank, we have a material in the form of a liquid, and this material can be solidified by exposing it to the UV rays. So now we have a laser, we have a UV rays. Now this will be moving the UV rays, and wherever it moves, it is going to consolidate the part. Something what we call it as photopolymerizations take place, right? It will be moving and photopolymerization take place. We get one layer, then the second layer, then the third layer, and finally we get a part layer. Now another thing is what where we have material in the form of powder, right? We all are aware of powder. So I can make a powder of a plastic polymer. I can make a powder of metals, of titanium alloys that are used in aerospace, or any other material, biocompatible material, which I can use in for implants. And then I'll use a laser, and laser will move again, and wherever the laser falls on the powder particle, they start sintering or they start melting, and once it happens, they start joining. As you can see over here, wherever the laser is moving, the powder particles are going to join together. So we make one layer, then we make the second layer, then the third layer, then the fourth layer, and finally we'll get a part ready. And this part that we are making will be looking exactly the same as what we have made in our solid model, the CAD model in the software, whatever we have made. So if I want to make an implant, I'll take the CT scan data, I'll take the dimensions, and I'll design the implant in the virtual world, in the CAD model. I'll take it, process it, and then I'll prepare the set of instructions, and I bring it to this 3D printer, put the material, it will start working, it will make the part, and then the part will be ready. If required, I'll do certain post processing, and then the implant will be ready. See, so any complexity we can make. And this is another category where we have the material in the form of sheets, and then I'll try to cut it wherever I want as per my CAD model, and then somehow I'll try to join one layer of the sheet with the other layer, and then the third layer, and so forth will build the part. Now, if you see this, all these technologies, the way they work are different, but there is a similarity. The similarity is all of these technologies are making part in a layer by layer fashion. One layer, then the second layer, then the third layer, and so forth. They will make the part ready. And once done, we'll have a part ready. So that is why all these different technologies falls under the umbrella of what we call it as additive manufacturing, right? So let me move forward. let me just before finishing, let me talk about the importance of the material, which is a very very important in any design. So if I want to make a product to solve a problem in the society, I need to work on the design. I have to decide which material I can use, because the material is going to affect the application. It is going to affect the shape, it's going to affect the dimensions, it's going to affect the durability of the product that we want to make, right? Whether if I want to make the phone, what kind of casing I want, right? Whether it's metallic or a polymer, what kind of polymer. If I want to make a medical device, it should be that medical device should be biocompatible, right? If it is coming into contact with the skin, or if it is coming in contact with any of the fluids of the body, it has to be biocompatible, right? So material plays a very very important role. Now, what kind of materials we can use in 3D printing or additive manufacturing? We can use polymers, plastics, we can use metals, we can use ceramics, and even we can use a composite, which is made of metal polymer, ceramic polymer, or metal ceramic. So we can use polymers, we can use metals, we can use ceramics, and even we can use composite, which are made up of different constituents. Right? We can use nano materials also in 3D printing, right? So it has a wide variety of technologies which are in 3D printing, and now we have a wide range of materials also which we can use. So if I want to work for something where I require biocompatibility, I'll select a material which is biocompatible. I want to work in a something, fabricate something for the aerospace department sector, then I'll pick a material which is aerospace grade material, right? If I want to make something for prototyping, I may use a plastic material, just if I'm using it for the prototyping purpose. So we have a wide variety of materials now available with us. We can pick the desired, we can pick which 3D printing I want a 3D printing technology which requires material in the form of liquid, or material in the form of powder, or material in the form of filament or sheet, whatever it is. So we have a lot of you can say scope variety through which we can actually select. We have a lot of variety of materials through which we can select, and then as per the requirement we can make the part. As per the requirement we can make a part ready. Okay, for example, just I'll take 5 more minutes and then we'll conclude. For example, if I want to make some kind of biomedical thing, then, and most of the biomedical devices, after, let's suppose it has to be used for surgery, it has to be sterilized, right? Sterilization. And sterilization, we expose that particular part maybe to the steam, or and pressure, or some kind of chemical. So I have to select a material which is biocompatible, as well as it should be able to handle the temperature and the pressure during sterilization, right? So the selection of the material plays a very very important role. Now, all these 3D printing materials, they are inseparable from the corresponding technology, and they are going to affect the functionality, as we discussed. They're going to affect the geometry, they're going to affect what kind of post processing we can do, right? What kind of certification we require, right? So now let me just quickly talk about the technology specific material. For example, I can use a thermoplastic. Okay, thermoplastic, we all know that it's a plastic which we can remelt it, and it solidifies on cooling, and again we can melt it, and we can use it in cycles, right? So this is the best choice. And if I want to educate a student, this is the best technology that which is affordable, which we can work on, and people can learn fuse filament fabrication. So here we are using thermoplastic, and the material is in the form of filament, and this filament material, we heat it, we extrude it through a nozzle, and then we print the part, which is ready as per the CAD model, and we'll get a part ready. You want to work on any of the projects, you have some idea, you can design your product, and you can use 3D printing to fabricate the parts. So this is very useful, right? So these are some of the printable polymers that we generally use. We we have polylactic acid, PLA, all these are thermoplastic material, right? ABS, we have polycarbonate, nylon is there, we have certain blends which we can use, PCABS and polyether ketone. These are some of the available choices through which we can use as per our application, right? If I want to make a more durable part which can sustain high temperature, let's suppose for some aerospace or some other application, then I'll go for, let's suppose, for polyether ketone. If I'm making a prototype, I can go with PLA material. I can go with ABS. PLA, in fact, is a biodegradable material also, right? So these are the some of the materials. We can make parts which are flexible also, right? Not only rigid part, but we can make parts which are flexible also. Okay. So, and we can make parts which are metallic in nature. We can make parts which are metallic in nature. Okay. So let me quickly sum of my presentation as for the time being. Let me just skip some of the slides and let me conclude, come to the conclusion part. Okay, all these are the different materials, and we can further discuss about materials which are available. All these are different materials. We have certain advantages. It's low cost. If I go for fused filament fabrication, it's very low cost, economical machines. We have less wastage of material, sustainable in nature. We can make change the material very easily. Okay, but again, everything has certain limitations, and so this particular technology also has certain limitations, like it can affect the mechanic low, it can give you low mechanical properties, inferior surface properties, low electrical properties because of the bonding in nature. And if you remember, we talked about making part in a layer by layer fashion. So when we make something in a layer by layer fashion and we try to join them together, these areas will always be the weak areas. So it has certain limitation as well, but still people are working on it, developing new materials to solve the problems associated with it. People are working on nanomaterials which can be used for 3D printing. But if I want to make it in nutshell, if I want to tell you that these 3D printing process that we have is something that is solving a lot of problem related to manufacturing, solving a lot of problem related to manufacturing. And this is one of the technology which has the potential. People are using it, and it has a lot of potential. In the coming years, we will be seeing a lot of industries using 3D printing, something that we can work on, we can learn this technology. And this is what we are doing over here. We are teaching students into this particular technology, right? So I think I need to finish now. I'll stop, and please feel free to contact for any other kind of uh, questions and you have. Please feel free. So I'll stop over here. I'll go back to ma'am.
Thank you so much, Dr. Vishal. So it was wonderful delight for discuss on design and material, 3D printing, prototyping of manufacturing, the building block for 3D printing regarding the aerospace, automobile, and more. And now I would request to the admission nominee, Dr. Mahendra Singh Kaswan, to be on the screen. Over to you, sir. Dr.
My screen is visible?
Your screen is visible. You can continue, Dr. Mahendra Singh.
Okay. First of all, thank you, Vishal sir, for such a nice seminar on 3D printing. And I appreciate the technologies of 3D printing will be the future for manufacturing and other industries like allied industry, like healthcare also. Uh, I just want to let you know that the programs of School of Mechanical Engineering, like that BTech Mechanical Engineering, BTech Mechatronics, BTech Automobile, BTech Aerospace. We are running currently in the School of Mechanical Engineering. I just want to share with you that Lovely Profession University is one of the prominent university, not only in India, but it is also being recognized uh, by the whole world. Recently, our university got A++ rank, grade uh, by NAC, and we got 3.68 score on 4-point scale, and this is the highest score in first cycle of accreditation among all the government and private universities within the India. So this grade basically signifies what kind of infrastructure, what kind of technologically integrated study mechanism we are having, what kind of facilities related to the sports cultural we are providing to the students for their holistic uh, improvement. I just want to let you know that Lovely Profession University Punjab is having one of the uh, uh, largest uh, campus in India, not only in terms of infrastructure, but in terms of hostel facilities too. We are the best among whole Asia in terms of capacity. We have different approvals related to University Grant Commission, for distance education, also National Council for Teacher Education, Indian Council of for Agriculture Research, National Assessment and Accreditation Council, NAC. We have approval from Pharmacy Council of India, Council of Architecture, Bar Council of India, Punjab State Council for Agriculture Education. So there are different approvals. There is n number of approvals we are having, and we have a world ranking. We are ranks LPU, in World University ranking, ranks LPU 23rd among top universities of India. And if I come to the discipline specific, we are second in business and economics. In engineering, we are in sixth in India by World University ranking. In clinical health, we are on eighth. In computer science, we are ninth, and in life sciences, we are at 12th position. And so there are the prominent ranking. And if I talk about sports, so Lovely Professional University create history. 12 out of 13 LPU students won Olympic medals, one gold medal by Neeraj Chopra, one silver medal, and two bronze medals. We are champion of 337 National Inter-University Youth Festival under the aegis of Association of Indian University, New Delhi. We are also uh, winning the historic National Sports Award, that is Maulana Abdul Kalam Azad Sports Trophy 2023, where we were first runner up. So there is a holistic improvement of the student in terms of sports also. We have hosted 106th Indian Science Congress, where Honorable Prime Minister PM Modi was present, and different scientists from all over the world, also prominent Nobel laureate were also present. So that is also significance the level of science and technology things are being done at the universities. So we have prominent speaker like Dalai Lama visited. We have recently concluded convocation. There are few glimpses from the film stars like Shah Rukh Khan, Deepika Padukone, prominent sports person like MS Dhoni visited our university. So there are different scenario that a student want to have within an organization. The student not only want to seek only for academic knowledge, whereas he want to explore ample opportunity for sports, cultural. So there is a holistic improvement of the person, not only in terms of academic, but also in terms of getting benefit in terms of mental health, in terms of developing a body where is that is having a healthy mind and healthy thinking for the nation and for all the society. So Lovely Professional University will provide ample opportunity for the student to explore a holistic person that is not only explore in the terms of education, but he traditional education system that, but also in terms of that a person also imbibe moral value within their mindset. So there are a few glimpses of the university. This is our campus central location. This is our auditorium. This is our facilities related to the labs. This is our library. This is a glimpse of a uni center. This is at the heart of the university, where you can get every daily use items. We have here the stores related to banks. Here the store related to laptops. Everything's will be there. for daily use. This gymnasium facility that is available in the university, eye care center. We have world class hospital in the within university. We also focus on the renewable energy sources. We have established solar panel on our buildings. So this is the glimpse of lovely profession university. This is the some glimpse of beautiful campus of lovely profession. This is the facility of the indoor stadium. We have all the facility related to shooting, swimming pool, basketball, badminton. This is the overview of the sports facility. So I just want to share with you how a candidate can apply for admission within the lovely profession university. So what the candidate have to do, you have to visit our website lpu.in. Even the candidate can call us, they can schedule call us with us, we will call them. We are live from 9 to 7. uh, we are available. Even we are available on Sunday from 9 to 5. Our campus for admission purpose is open from 9 to 5. You can call us, you can chat with on WhatsApp, and you can have a video counseling with us. And you can also visit our in our offices that are situated in different cities within Pan India. So what the candidate have to do? I just want to share with you that we have left with fewer seats. So I appreciate if you can apply for admissions or LPNest application as soon as possible. So what you have to do, you have to visit lpu.in. Thereafter, you have to click on admission. And I'm taking a glimpse of, like, for example, of mechanical engineering course. So in admission, you will click on regular programs. Then so it is taking some time. Okay, so here the candidate has to select, like, for example, mechanical engineering I'm talking. So here he will select engineering, then he will click on just 1 minute, mechanical engineering. Then the different courses of mechanical engineering will be there. Oh, by mistake I have selected computer science. Okay, no problem. So here, if I am talking about computer science, so there is a lot of option of computer science will be there. Candidate can click on any suitable option. Okay, so let's say I'm clicking on BTech computer science. So here all the details related to what kind of duration of the course, what kind of eligibility criteria, fee structure, okay, and what kind of courses in different semester we will have, candidate will have different kind of tie-ups with the industries. All the things will be available. How to apply for the candidate can have apply here. Okay, so important dates will be there. Okay, so here important dates, if I'm talking, so we have leftover with minimum seats. So I request everyone to be present here to apply for admission as soon as possible in our program. The fees is written here, what kind of scholarship we are offering here. So everything is mentioned here. And if still any student have any confusion at any stage, they can call us. So registration is already start, and examination candidate can select within their choice. We are offering examination candidate can give from their home, from their laptop, desktop, or they can appear from the center based exam that will be also held on laptop or desktop. Exam result will be declared within 48 hours, and they have to take admission within 7 days, subject to the availability of the seats. So we have limited seats in the programs related to mechanical engineering. Every discipline we have limited seat, and we are left over with minimum seats. So I request everyone to proceed for admission as soon as possible, so that they can take advantage for the highest scholarship, and they can nurture their career within the domains of engineering and other allied aspects of management and other programs where we are offering a lot of programs that is not being offered by many of the university within India. So thank you so much for connecting with us.
Thank you so much, Dr. Mahinder. As I can see, there are some more questions from our participants. Can we take questions, Dr. Vishal?
Sure, ma'am. Yes, we can
Yes,
take.
someone is asking here, respected sir, is there a additive manufacturing laboratory at mechanical engineering block at LPU? And is there any offline summer internship running for the topic on 3D printing?
Yes, we do have 3D printing machines over here, which are based on extrusion, and yes, we are planning. We generally offer summer internship, and regularly this time also we are going to offer a summer internship. So people who want to take, they can enroll in that particular summer internship.
Thank you so much, Dr. Vishal. Someone is also asking here, Gurpreet is asking here, how has the 3D printing revolutionized traditional processes?
Okay, so the biggest thing 3D printing has, which it has contributed, is in terms of providing design freedom, as I said earlier. So traditionally, what we have to do is, for example, if I want to make something by machining, I need a tool and I need a workpiece, and then I have to, make contact of the workpiece with the tool, and I have to cut the material, and then, or in other words, I have to remove the excess material, and then I'll get my part ready. But in 3D printing, what we have is we only deposit the material which is required to build the part. To some extent, we are actually saving the part. There is no removal of the part, but we are adding the material, and that material which is only required to make the part. That means instead of cutting the part and getting the waste of the material, what we are doing is we are adding the material. So we have it provides a lot of saves the material wastage is minimized, you can say. It has helped in making any complex part, as I said earlier. So this is one thing, because earlier what we have is we have a restrictions of manufacturing, right? So if I want to do injection molding, I have to make the tool, then only I can do injection molding. But here what we have is no requirement of tool. See, no requirement. We have the CAD model. The same CAD model will slice, prepare the G code, and then will print the part, make the part ready. So it has affected traditional manufacturing a lot in terms of material save, in terms saving the material, in terms of making complex part, right?
Thank you so much, Dr. Vishal and Dr. Mahinder. I hope all the participants got the answers from our expert. As we come to the end of this webinar, I want to express my deepest gratitude to our experts for sharing their valuable insights and expertise with us. Your presence, enthusiasm, and active participation have made this experience truly special. Hopefully, the attendees found this webinar to be valuable and be able to utilize the information for better decision making regarding their admissions. If anyone want to access this webinar, they can visit our website, that is lpu.in, or can be accessed on YouTube also. Stay connected with us for future webinars. Until we meet again, with the permission of my seniors, I would be signing off this webinar. Take care and goodbye. Have a nice day.